In this video, we want to look at differentiation of inverse trigonometric functions. If, for example, we say that y is equal to sine inverse of x, then we want to find the y dx. First of all, if we make x subject of the formula, x will be equal to sine y. X will be equal to sine y. And if x is equal to sine y and we differentiate x with respect to y, we're going to have cos y. If we differentiate it, we'll have cos y. Now, there is a trigonometric function that says that cos square theta, or since we're having y here, let's use y, that cos square y is equal to, or let me say cos square y plus sine square y is equal to 1. So that if we make cos square y subject of the formula, this sine square y will cross over and become minus. So cos square y will be equal to 1 minus sine square y. Because of this, we already know here now that x is sine y. Because of that, we can also say that cos square y is equal to 1 minus, this is x, so x squared, since it has squared, since x is sine y. Now we can rewrite cos square y, or we can rewrite only cos y to be square root of 1 minus x squared. Because of that, we can rewrite the dy dx as 1 over 1 minus root x. If we follow the same way, we can also find check this, that y is equal to cos inverse of x, and we now want to find dy dx. We can still say that let's begin by saying that x is equal to cos y. If x is equal to cos y, then dy dx, or first of all, let's differentiate x with respect to y. And if we differentiate that, we're going to get negative sine y. So that if we now get dy dx, it will now be negative 1 over sine y, because of the inverse. Still using the same trigonometric function, that cos square x plus, or let's use y, cos square y plus sine square y equals 1. And here now we're making sine square subject of the formula. Sine square y will now be 1 minus cos square coming over cos square y. Remember that x is cos y, so we can now say that sine y alone will now be equal to, or let's still say sine square x, let's break it down, sine square y will be equal to 1 minus x squared, because cos x is y, x is cos y. So here, therefore, we can now write for only sine y, which will now be square root of 1 minus x squared. And because of that, dy dx will now be negative 1 over square root of 1 minus x squared. Let's also look at another question. If tan inverse of x is equal to y, then find dy dx. So why is this? Now we can say that let x be equal to tan y alone, so that if we differentiate this x with respect to y, we're going to have sec square y. And this sec square y, we can still express it as 1 plus tan square y in terms of tan. Now, since we're dealing with tan and we said that x is tan y, so we can rewrite this now in the place of x. We can now say that dx dy is equal to 1 plus, remove it as x, since it's squared, we put square. Therefore, if we now do dy dx, which is inverse of this, it will now be 1 over 1 plus x squared.